This is what the audience will be hearing at the San Francisco Opera House, the full sound of a 44-rank organ. But this is what the musician will be playing, a little Apple IIe computer, plus a hardware-software package called the Cathedral 100. Computers can make beautiful music, as we'll find out today on this edition of the Computer Chronicles.
The Computer Chronicles is made possible by Leading Edge, makers of IBM-compatible computer systems, including Lotus lookalike spreadsheet, word processing with spelling correction, communication software, and Hayes-compatible 1200 baud modem. Leading Edge with over 1,000 service centers nationwide. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover developments in computer technology worldwide.
Welcome to the Computer Chronicles. I'm Stuart Chaffee. This is Gary Kildall. And Gary, this is the Casio SK-1. These computer keyboards have really come a long way in 2 years since we last did a show on computers and music. This little thing costs about $100. It does all the usual things. It has a built-in synthesizer. And watch what else this little guy can do. It has a digital sampler so that...
Computer Chronicles.
Computer Chronicles. Computer Chronicles.
Computer Chronicles.
You can do anything you want with this keyboard. It's quite amazing. It seems to me one of the reasons computers and music have moved along so quickly has been because of the establishment of a standard, in this case the MIDI standard.
Well, Stuart, the whole personal computer industry is really based upon standards, starting with the floppy disk in the early 70s, RS-232, the IBM motherboard, processors, operating systems, languages, all these things are basic standards that we've all adhered to. The MIDI standard is going to give us a whole bunch of new, interesting, and fun applications, I think.
We're going to see some of those today. We'll take a look at the Commodore Amiga, the Atari ST, see what kind of music you can get out of those machines. We'll look at the new Apple IIgs and see how good it is with music and sound. We're going to start out by going to a computer expo, which had a concert featuring a Macintosh.
Gary Leuenberger is a musician, a composer, a writer, and a performer. With a synthesizer, he can mimic any traditional instrument and invent a few new ones as well. The equipment that makes it possible is a combination of software and hardware that communicates with his synthesizer through a musical instrument digital interface, or MIDI port. The process begins on a Macintosh screen with a program called Professional Composer to lay the foundation of the piece. The program counts out and automatically numbers the measures, creating a musical sketch on which to place notes. Gary can then move directly to his keyboard, the output of which feeds into the Mac, again through a MIDI port. Once the rough draft is in the machine's memory, it can be played back and manipulated. Gary uses a digital sequencer with 8 MIDI ports to assign the different voices to 8 separate synthesizers. If he adds a drum part, the MIDI clock will synchronize the beat to the tempo of the piece.
I start the drum machine and I start
When the fine-tuning is completed, the MIDI data goes to a Yamaha digital sequencer, which controls the playback of the completed piece through the 8 synthesizers. Gary can still change the piece at any point or play along in real time. Synthesizers began to appear in the 1960s and found a special niche in the musical world over the next decade. Now, with the advent of MIDI, electronic music can take center stage.
Joining us now in the studio is Chris French, a music software consultant with Activision. And sitting next to Chris is Bob Moore, president of Hybrid Arts of Los Angeles. Gary?
Stuart, this is a really excellent example of a MIDI application. This is a music studio. It's a $70 package, runs on your Atari 520 ST, and lets you compose and play back music. So, Chris, can you show us the product?
Sure, I'd be glad to. Most of the operations are done just with the mouse alone. The cursor,
that feedback we're hearing is real-time feedback as you move a note on the staff?
That's right. As you move the note up and down the staff, you can hear the computer play that note, and it also tells you from the message board what the note is. I can select most music notation, measure bars, ties. I've got 15 different instrument colors to work with to distinguish one sound from another. I've got triplets, accents, dotted notes, and here I can select all the notes from a whole note to a 30-second note, and that's with tempos from 57 quarter notes a minute to 200 quarter notes a minute, which is quite fast. Here we have rests. I can put an accidental on a note to change its key or stay in the current key.
So you've got all the features that a composer would be using.
Just about all the notation you need.
Show us a piece of music that you would play just using the Atari sound chip by itself.
Once again, just drag the mouse up to File, hit Song Files, and I want to load a song. I want to load a song called Ends Vision.
Which you wrote?
Yes, I composed this.
Okay.
I made up my own sounds with the software and then composed with them.
Okay.
Each different color here is a different sound. So now take the mouse, the cursor down to scroll, and the music will scroll.
Okay, now we're just using the Atari right now, nothing else.
That's correct. The sound chip in the Atari is playing all the music.
We can stop that for a second. And now you've got a million toys over here. Introduce these other players and tell me what you're going to do next.
Okay, these are MIDI instruments. We're using a MIDI cable out of the back of the Atari ST, which is the MIDI port is built in, and we're using a Casio CZ-101, a tone generator from Yamaha called a TX7. We've got a Latin percussion drum machine and a regular trap set drum machine. These are all MIDI instruments, and the notes will tell the MIDI instruments what to play as the music is being scrolled by.
Okay, so run this whole orchestra by for us.
Okay, I'll dump this song with a trash can, go back to my file, song files, and I want to load a song. Actually, this was a popular song called Axel F from the movie Beverly Hills Cop. This is not the original recording, though. I wrote this music onto the screen, found sounds in my synthesizers and drum machines that I thought matched the original song, and wrote it onto the screen, saved it to disk, and this is what you get. And there you have it. If we look just about where the dot is, that is the music that is being read, and the MIDI data is spit out to the machines.
And how long did it take you to put together that song?
This song took about 3.5 hours.
Not too bad.
But
Bob, let's turn to you now. What is Hybrid Arts doing? What kinds of music products are you into?
We manufacture a whole series of products for the 8-bit Atari computer and the 16-bit Atari computer.
And you have something called ADAP?
Right. ADAP is a system that we refer to as the tapeless recording studio or digital audio workstation.
Okay, you're going to show it to us? And
yes.
It's over there?
Yes.
Can we go over there?
Sure.
Okay, let's do it.
The music studio is software really for the consumer market. And I understand, Bob, you have products for both consumers and professionals. Can you show us a consumer product?
Sure. I'll show you Easy Track. Easy Track is a program sold for $65 in the mega chain stores. With Easy Track, I'm able to start and stop the drum machine within the synthesizer, change patches. That is, this machine sends commands to this synthesizer, which is under the computer, to change patches, make voice changes, and start and stop drum machines, that sort of thing. So I can stop wherever I want to and continue on.
Now, give me a quick summary of what Easy Track is doing with the Casio keyboard.
Sure. What Easy Track is able to do is I'm able to turn tracks off and on.
So you really got a recording studio here is what you're doing.
Sorry.
And when you get all these commands together, you play the music back again and maybe record that result in.
Sure. I can start and stop the drum machine and play a part. Keep that, hear that back. You can see the part that I just played there. If I want to, I can actually go up and correct the timing on that track. So correct to, say, a 16th note from that track to that track, replace it, play it. Now the timing has been corrected on that
Bob,
track.
now at the high end, you've got ADAP. What does that do?
ADAP allows me to take, well, replace tape. Oh, let's get out of this. ADAP is a 16-bit recording system. that, for the most part, in our eyes, replaces tape machines, and that's our eventual goal, is actually replace tape machines, the tapeless recording studio. What ADAP is, the version that I brought with me is a 2-channel stereo, high-end +4 type DBM input recording system, 16-bit. Right now, this version that I'm showing you is CD compatible.
Okay. So what would a professional system equivalent to this cost?
Well, if you went to as far as some competitors who are planning on within 5 years to release such a system, it'd be around $300,000, something like that.
And
Our system, the low-end system is $2,000. The high-end system is $15,000.
Okay, now what are you doing with the CD player here?
CD player, I can start from here, and it's a sound source. The stereo outs of this are patched to the stereo inputs of our recording system. The recording system takes the analog information from here, digitizes it, saves it into RAM, and then I can play that back and manipulate that information.
Okay, so it's being captured, the sound's being captured now?
Right, playing from here, I've captured that sound. I can grab a section if I want to. I can zoom in if I want to, take a close look at what I'm about to capture. I can scroll that around, grab a section, listen to that.
So this is sort of like the equivalent of a word processing system, but for music instead.
Right. I can grab a section, place it anywhere else in the song that I'd like to.
Okay. So you can take any audio source, put it in here, massage it, play with it, do anything you want with the music.
And actually, this system is a lot more than just a recording system. I'm also able to take other functions, such as an oscilloscope, if I want to, or a mixing system. That is, we're planning on being able to offer 64-track overdub capability.
Bob, we're out of time, I'm afraid. Okay, Gary, we've seen what you can do with an Atari ST. In just a minute, we're going to see what you can do with an Amiga and the new Apple IIgs if you're interested in music, so stay with us. We've now replaced all the major machines here for another demonstration. We have a new human being, and that's Chris Potter of Memetics Corporation, a new synthesizer, the Yamaha DX100, and a new computer, the Commodore Amiga.
Now, Chris has a hardware and software product here called Soundscape, and can you show it to us?
Sure. Soundscape offers a recording environment. It's actually a music operating environment that allows me to play up to 16 external synthesizers, as well as using internal sampled sounds. I've got a little piece in here that I'll play. You can see it playing on the player piano, and what I'm hoping to do is take the sound of the organ and replace it with the sound of this wine glass here.
Now, this sound's coming internally from the Amiga.
These are all internal sounds. I'm not really using the DX100 at all. So go in. As I choose different options here, you can see the various menus pop up, and there are many, many options within the Soundscape environment. I'll go into sample, and that's the current sound of the organ that was in there. And I'm going to go in and sample the wine glass. Should have the wine glass here.
So you just created a new voice, essentially.
Right, and I got to remember to turn off looping here. There we go. And you can see it says new sample up here. And now I'll play back the piece. And we have the wine glass on there. The Amiga is particularly well suited for this because it has 4 digital analog converters in it, so it can play back sounds very well. Also, in addition, as I'm playing the sound, I can have a background task, and here I have some of the Amiga's graphics running in the background, and these could actually be edited and played around with. You know, I could actually go in and play with the pictures.
How does that sample compare with, say, the sample you find in a compact disc audio?
How do you mean?
Well, is it a better quality sample?
Oh, I would say it was less quality sound, but it's perfectly adequate for the home studio. You're able to do, you know, sample anything, sample your cat, and things like that.
Chris, what's the cost of Soundscape, the system?
The Soundscape system is $149 for the system, and that includes all the modules you're seeing. The sampler itself is a small box here that plugs right into the port, and it's another $99 with software.
So this could be used by the amateur musician at home or even a more professional musician?
Yes, it's already being used by several professional musicians. It offers unlimited overtrack capability, limited only by memory, and since you can go up to 8 megabytes.
And we're limited by time.
Yes.
Thank you very much. And Gary, we're going to go take a look now at the new Apple IIgs and see what kind of music we can get out of it.
Thank
Let's
you.
go. Thank you, Chris. Sitting here patiently waiting for us has been Curtis Sasaki. Curtis is the product manager for the IIgs at Apple.
Stuart, we've seen a lot of attention given to the Amiga and the Atari because of their sound processing capabilities, and now we get a chance to see the recent offering from Apple. It's called the Apple II GS. I guess the G stands for graphics and S for sound. Can you tell us about it, Curtis?
Sure. What we've done is we brought over the Ensoniq sound chip from a Mirage keyboard and put it as part of the Apple II GS. So that allows us to do both digitizing and synthesizing of songs and music. What I'll play is a sample off of a compact disc player.
Okay, so this was a digitized signal off a compact disc stored in memory?
That's correct.
TGS? Okay.
You can either store it in memory or save it onto a floppy disk.
What's the capacity? How much can you store? How much can you digitize?
You can digitize up to as much memory you have into the system. The Apple II GS, you can have up to 8 megabytes of memory, so you can have a waveform of that length.
Now this particular sequence is how long, this segment?
This is about 600K in length.
And that's how many seconds?
About 28 seconds.
28 seconds, okay.
And this demonstration you're showing us, this isn't a particular software product. This is just a demonstration program to show us how you can digitize sound. So
That's
people
correct.
aren't going to go out and buy this particular thing, whatever it is. Okay, what about the synthesizing end?
In synthesizing, you're probably familiar with a program called Music Construction Set that was brought out on the original Apple II. The programmer, Will Harvey, has had quite a bit of fun with the new machine and the Ensoniq sound chip.
Now, the idea of the music construction set is to, what, you basically can make up the music yourself on the machine, then play it back. It's digitized and then play it back again?
Actually, you compose music on a music sheet, as you see on the screen here. Let me load in a sample.
So you're pulling up a file of a song that's already been written?
That's correct. So you can see the notes on the screen.
And there's the score.
We'll say
and you
play.
can play it. Okay. And all those icons on the right would be your usual composition maneuvers and controls you would have if you wanted to write that music. And again, the big difference between what you can do now and what you could do with Music Instruction Set on the Apple IIe is what?
The original version on the Apple II allows you to play 4 voices. This allows you to play 15 voices all at the same time.
How does that sound processing compare with the Atari and the Amiga?
Well, we believe we have a very powerful horse-powered engine in here that allows you to play back that many voices all at the same time.
Okay, Curtis, thank you. Now we've seen what the Apple II GS can do. We've seen lots of computers that can play music. Now we're going to take a look at a computer that can listen to music. Wendy Woods has that report from Stanford.
Researchers at Stanford's Center for Computer Research in Music and Acoustics are trying to imitate the human ear with a computer program. Specifically, the computer must not only hear the music, but distinguish between several notes or harmonics played at once. In this experiment, a piano solo was recorded through a microphone onto tape. Researchers wanted to find out if the computer could play back the performance with the identical pitch, rhythm, and harmonics. The experiment required artificial intelligence, so the powerful programming language called Lisp was employed.
The research entails trying to find algorithms which, say, imitate how our ear understands musical signals. So using Lisp, we have a good workbench or tool bench for this kind of experimentation.
The tools also included a mini computer, signal processor, and a synthesizer. This was the result. The piano is heard first, followed by the computer's reproduction accompanying the piano music. Another part of the software will write a score for the music and print it out. The entire process of analyzing one 30-second piece of music takes an entire afternoon for Stanford's Foonly mini computer. But as faster, more powerful microprocessors reach the market, the process could happen live time. For the Computer Chronicles, I'm Wendy Woods.
Joining us now in the studio is David Schwartz, president of CompuSonics of Palo Alto, California. And back with us is George Morrow, our frequent commentator and sometime host here.
Stuart, I just wanted to mention we finally got all the computers on. We got an IBM PC now.
But there's something else there.
Yeah, I think it's important to point out here, this is a product that David has called CompuSonics, and it's a recorder, as I understand it. I'll have David explain a lot more about that. These two pieces of equipment don't normally go with it.
Right.
And it's part of the editing system he's also going to show us. So, David, could you describe the CompuSonics?
Well, the Compusonics DSP-1000 is the world's first optical disc audio recorder. So unlike tape recorders or any other type of recording device you've ever seen before, this machine records on rotating computer memories, discs. This is an optical disc used in the computer industry for recording, say, insurance company data or records or maps or whatever, oil company records. In this case, we've recorded music. You can actually see it recorded on the disc here.
It's a little bit small for me to see the music, but I think that's important to point out that the compact discs that people are used to nowadays, the little shiny silver things, they're what's called a read-only memory, and that is you can't write on those things, you can't record onto them. And so this gives you basically the quality of a CD audio, but you have the ability to record on it also. Is that correct?
That's the important thing. It's recordable, and not just recordable. Recordable in a permanent way. I'm not sure if you've ever had a tape wear out on you, or jam, or get destroyed, or something like that, or just plain fall apart.
Even more than that, I mean, you can massage and manipulate this music on the disc once you've recorded it, can't you?
Of course. Well, it's data.
Yeah, show us that.
Data.
Yeah.
This is a program that we call the DSP-1000 PC program, which is a software disk for the IBM PC. It will also be available for the Apple Macintosh in a very similar form, of course in black and white. And it allows you to list the tunes on a disk, database them, if you will, play them from the function keys on the IBM PC keyboard, or I think even more importantly, process the data. And that is a process like EQ, boosting the mid-range or reducing the level of the bass, for example. Or let's say that you have noise on your
Can you show
disc.
us how you'd
Well, this key here, process, of course the process key, we move to a noise removal process screen, which automatically searches the data for impulse noise.
So the computer found that blip.
Exactly. This right here is probably a scratch on the record that was recorded, of course, in the data on the disk. Then the computer proposes to replace the scratch with the average signal from both sides of the scratch. And of course, you listen to that, and if you agree with the computer software, you push the F10 key and remove it.
And you edit that piece of music. Now, you recorded, I think, on this compact disc, a piece of music from earlier in the show, didn't you?
Yes, I did. I was up in your control room recording.
Can you prove that you did that for us, so this really works?
Here we go.
Okay, and that's a piece of music we heard earlier in the show.
That was a MIDI synthesized piece, synthesized in a computer and then fed out analog and right into the input jacks on this machine.
George, I want to ask you, now I know you're a collector of 78 records with lots of scratches on them.
That's right.
What do you see you could do with something like this?
First of all, Stuart, I think I could probably take the worst of the noise out of my records. I could restore a lot of these historic recordings to something close to what they were in the very beginning. But then what this makes possible is something much more than that. If I did some analysis about the early acoustic recordings and then could take out the effects of those horns, then perhaps we could hear some of those early recordings as they might have actually sounded in the studios. It's one of the most exciting things that you can imagine.
David, what is the market for this machine, other than weird guys like George here?
Well, it's really for people at the top end of the audio market, audiophiles, who are extremely serious about their music and can afford
just like me,
a $7,000 recording device that is the state of the art in recording.
Except I can't afford it.
And what is the price of the medium itself?
Right now, these are $100 each, and they record about 80 minutes of stereo on one side, or a slightly more expensive disc recording 80 minutes on each side.
David, one last question, just about out of time. Do you see this thing ever coming down in price where it really does become a consumer item?
I see it coming down an order of magnitude, that is to $700, providing that the concept becomes a little more popular now that we're just introducing it.
David, fascinating. George, thank you. We're out of time. Thank you for joining us. We'll be back in just a minute with this week's Computer News.
Chase, sitting in for Stuart Chaffee. In the random access file this week, look out for Commodore's latest promotion of its Amiga computer. The price of an Amiga 1000 system with a color monitor and 256K of memory falls between $500 and $1,490. Also, if you buy an Amiga on Commodore credit this fall, you won't have to make your first payment until February 1987. Lotus announced plans to combine analysis software with financial information on compact discs, making it the first major software company to enter this emerging market. The system, called OneSource, comes with 8 databases containing 20 years of stock price information. Updated discs will be prepared weekly. Lotus expects to sell the service to banks, investment firms, and large corporations. Intel Corporation is expected to announce an agreement with IBM that will push it into the fast-growing business of making semi-customized computer chips. IBM is the world's largest maker of chips, all for its own use, and is well known for its sophisticated technology. Analysts expect this agreement to allow Intel to use some IBM technology for building semi-customized chips. This could be the first time IBM technology would be used to make chips for others. And as if it weren't enough companies making IBM lookalikes, now you can take a course to learn how to make your own clone at home. In California, San Jose State University will offer a 4-hour class that teaches students how to put together an IBM PC XT compatible system for less than $800. And in Florida this month, the National Association of Accountants will offer a similar class, which includes all the materials necessary to assemble a PC in about 3 hours. More classes are expected to pop up. Time for a look at software. Here's Paul Schindler with this week's review.
You know, it's true what they say, the world is a carousel of color. If you're among the thousands of people switching to an EGA color graphics adapter each month, you should already know that the exciting new graphics standard can display 16 colors out of a total of 64 available. The question then arises, how do you get at the other 48 colors that don't pop up each time you boot your system? Well, you can do it with tricky programming, or you can change colors with Color Magic, a nifty utility program produced by the people who brought you the Volkswriter word processing package. Now, Color Magic gives you 16 canned color spectrums. EGA people insist on calling them palettes. One of the available palettes is an especially kinky one called Colors Not Found in Nature. Now, the whole idea may sound a trifle pretentious, but the right combination of colors can really improve the comfort of staring at a CRT for long periods. Besides, designer screens are fun, and former monochrome users will delight in mixing and matching colors. Color Magic, $40 from Lifetree Software of Monterey, California. For the Computer Chronicles, I'm Paul Schindler.
In the legislative update file, the IRS continues its automation program. Businesses from anywhere in the country and individuals from 7 sample cities will be able to file 1986 income tax returns electronically. For the first time, electronic filers will be able to get an electronic refund if they include a number on their form identifying their bank. The IRS will instruct the Treasury Department to use electronic transfers to credit the taxpayer's bank account. Wondering how to send your latest drawing to a friend? Telegraphics of Cambridge, Massachusetts announced a $99 program that allows you to transmit graphic images via electronic mail. The program, called Television, uses compression and encoding techniques to reduce the amount of data necessary to define an image, then sends it through commercial email services. The recipient needs to use another copy of Television to decode the image. The program is available for IBM PCs and compatibles. Finally, are you afraid of computers? If so, you're not alone. 1/3 of all workers in the United States reportedly experience some form of uneasiness when they work at a computer, and about 1 in 20 suffer severe reactions. Wonder if you could call this an allergic reaction. Well, that's it for this week's Computer Chronicles.
The Computer Chronicles is made possible by Leading Edge, makers of IBM-compatible computer systems, including Lotus lookalike spreadsheet, word processing with spelling correction, communication software, and Hayes-compatible 1200 baud modem. Leading Edge with over 1,000 service centers nationwide. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover developments in computer technology worldwide.